Next section on the exam is 14.6, the chain rule. This is where you have a function and its variables depend on other things. So for instance, if f depends on x, y, and z, and each of x, y, and z further depend upon q, r, and s, then if you can ask the question, how does f change with respect to r? Or how does f change with respect to q? To do this, we can use something like this diagram right here. First, you take the highest level function, and then we work down towards its variables. F is a function of these three variables, and then each three of these variables are functions of these three functions, q, r, and s. So for instance, if you wanted to know the rate of change right here of f with respect to q, you first consider all possible ways to go from f to q. Well, you can go this way. We can go this way. Or you can go through z. So, let's focus on this first branch. F depends on x. So, depending on that, on the very nature of that relationship, f does depend on x, so there is this rate of change associated with f and x. Similarly, since x is a function of q, r, and s, x also has a rate of change associated with q. So we have a rate of change, f with respect to x, and a rate of change, x, with respect to q. So this first path is exactly captured right here. And you can see that conceptually, the changes in x kind of cancel out, and we are left with, conceptually, a rate of change of f with respect to q. So you rinse and repeat this multiplication for each path that you have, and then you just add the paths together until you've captured all possible ways to travel from f to q. One little thing, we're only doing downward movement, so there is no we're not doing anything like that. It's just that. Strictly downward motion. Lastly, we have this idea of implicit differentiation. So for instance, if we have something like, we'll do an example here. If I have 2x sine of yz plus z cubed equals 3, then the rate of change of z with respect to x, well, what is that? Well, you don't need to prove this formula, and I won't prove it in this video. That's beyond the scope of what you need to know. You just need to know how to use this. So it says it's equal to negative f sub x f sub z. So here they're assuming they're starting with an equation of this form. And again, this doesn't even have to be 0. This could just be some constant. So here that constant for me is 3. So that's fine. I'll leave 3 alone then. So what I'll do here is I will define this left-hand side. All of my variables are on the one side isolated. Only constants remain on the right-hand side. I'm going to define this to be capital F. Then capital F sub x is the x partial of that left-hand side, which is 2 sine of yz, and f sub z, for instance, is 2x z cosine yz. We get this copy of y because the partial of this with respect to z is y, so we multiply by the derivative of the inside, plus 3z squared. So the rate of change of z with respect to x turns out to be negative 2 sine yz all over 2xy cosine yz plus 3z squared. This is no different than the implicit differentiation you did in Calc 1, but in Calc 1 they didn't show you this nifty formula.